So now we'll see the video in the last class what we were watching. So we'll start the same video here. Okay. Here we can use only we have the one candidate item. So here we are saying कि apiary algorithm has a main principle that if an item set is infrequent, its corresponding the superset of the infrequent item set also will be the infrequent. Okay. So this is the main contribution of the apiary algorithm, basic principle of the apiary algorithm. And now we'll see in details how apiary algorithm is being worked. Okay. Are you listening to me?
Yes, sir.
Yes, sir.
Okay. So total number of candidates will be drastically reduced to 41 to 13. Okay. So basic principle that if an item is infrequent, its corresponding superset will be all its superset will be the infrequent. That is we see. So whenever bread beer, it is already this combination bread beer. If you add anything milk, obviously it is going to be infrequent. So therefore no need for generating the candidate involving the bread and beer. Now in more formal way, the apiary algorithm. First you generate the one frequent item. That means you count the number of occurrence of each item in the transaction database. So that is let k equal to 1, generate the frequent item set of length 1. You count it and then you discard if it does not support the minimum count. Now repeat until no new frequent item set are identified. What do you do? What do you do it? Generate length k plus 1 candidate item set from the length of the k frequent item set. So you are giving the length of k and from here you generate the length of k plus 1. Basically say suppose you have A, B, C. These are the frequent items. How do you make it two frequent item set? So you combine with AB, you will get AB. Combine with AC, you will get AC. And then you combine with BC, so you will get BC. Okay. Now you consider these all three are frequent. Then how do you make it item set with length 3? So you combine with AB with AC. So then AB, AA, BC, but this cannot be combined. Okay, will come later. So then this when you combine it, then what will happen? So A, this is same, and then we have B, we have C. So then combine you will have A, B, C. Okay, I'll say this one. So generate the length k plus 1 candidate item set from the length of the k frequent item set and prune the candidate item set containing the subset of length k that are infrequent. So after combining this one, we'll again check whether this item set is frequent or not. Okay. Count the subset of the each candidate by scanning the database. So obviously, how do you check whether this item set is frequent? So you have to scan the data set and eliminate that are infrequent, leaving only those that are frequent. Obviously, in the earlier example, you can see here. So when we will combine with these three, we combine with these three. So then bread, milk. So we combine with here. Let's say we want to combine AB with AC. Then we'll get A, B, C. A, B, C. So similarly, earlier we had A, B, and then AC. So then we'll get it A, B, C. So A will be common. So when we are combining AB with AB with AC, so say suppose this length is 2, this length is also 2. So if we combine, we want to get the length, say 2 plus 1. So then we have to see before the say suppose this is k length. So before the k minus 1 length, all item will be the same. So here this is same, then we can combine and form ABC. So this is one example. Now is how to count the number of occurrences of the each item. So say suppose, so here I must mention one thing. This slide has been taken from the Bipin Kumar slides. Okay, so you can say hardly there is any change, and maybe there are little changes, but mostly it is from the Bipin Kumar, because it will be in public domain, so I need to acknowledge their contribution. So Bipin Kumar book is the 10 what is called is data mining book, our textbooks, Bipin Kumar. Okay, 10 and Bipin Kumar book. Okay. So bread and milk. So obviously this will form some item set. So one item set can be bread, another item set can be bread and milk. So what we do it, we'll check. Say suppose we want to check this item, wherever it is this item set is occurring in the any one of the candidate item set. So that will be the actually very expensive. So therefore what is done is, so hash structure is formed based on the number of unique item present in the transaction data set. So that how I will do it, then I will come in the next. Let's say suppose you have the 15 candidate item set of claim 3. Okay, so that candidate item say it's like, first what I said, first you have to generate the candidate item set. Candidate item set means, let's say in earlier example we have, say if I go here, so we have the bread, we'll arrange this item in lexicographical order. Okay, so here if you see, the bread will come first, bread will be 1, and then we have coke, so but this is infrequent. So then what next? Oh, bread. So before that we have beer, right? So this will be 1, this will be 2, and then coke. Then what next? So then we have the diaper. So this is 3. Then egg. So it is cross. Then we have, is it right? So we have beer, then bread, then coke, diaper, and then milk. So then total unique item set is 1, 2, 3, and 4. Okay, so total number of unique item set is, because after one item set we'll have the 1, 2, 3, 4. These are the total item set. So what we do it to avoid, say like bread and beer and bread, so it is representing the same item set. What we do it, we arrange the each item set in a lexicographical order. So this is the arrange here, that is 1, 2, 3, 4. Now everything will represent as a this number. Okay, instead of the original item also you can do, but it represent the this order 1, 2, 3, 4. And from here we generate the candidate item set. Once we generate the candidate item set, then we'll go for the validating whether the candidate item set is frequent or not. But for doing so, as we have seen, it is computationally intensive. So therefore what we do it, we'll use the some hash tree structure. So let's say here, suppose we have 15 candidate item set is generated. Of each item set length is 3. So it can be 2, 1, 2, 3, 4. So for in this example, how to generate the hash structure of the candidate item set. So we generate the 15 candidate item set. So what are those candidate item set? So these are the 1, 4, 5. It can be 1, 1, 2, 4, 4, 5, 7, and so on. Okay. Now I have to generate the hash structure of the, so please note that, say you assume that there are 15 candidate item set. Okay, and once 15 candidate item set, then we will generate the hash tree. Why do we generate the hash tree? Because what is the objective? Objective is that we have to find the whether this particular item set that is frequent or not. So while generating the this item set, we are not actually checking in the data set. First we generate the candidate item set and then we'll prune them. Okay, prune them if that is not frequent. So for finding whether these item set are really frequent or not, so we have to have a hash tree. So that will speed up the entire process. Okay. candidate item set. So here is the tree for the candidate item set. Okay. Now once we generate the hash tree, now we'll go to the each transaction, and the each transaction also will be converted from each transaction. Let's say I have a transaction 1 2 3 5 6. From here I'll generate the all possible candidate item set, and then I'll trace the tree, and then we'll increment the counter wherever this is matching with the candidate item set with the, sorry, it is matching the item set contained in the transaction and the item set into the hash tree. So that is, we'll show you with one example here. So now here is hash function is on the left side. You can see hash function on the left side. What is that? So there are 3 children here on the root. So, and it is using the mod 3 function. So hash function of, say, let's say h of p is nothing but p mod 3. So what is that? P is nothing but the value of the item. So therefore, if the any item set starting with 1, it should go on the left side. Any item set starting with 2, it will go on the middle, and any item set starting with 3, it will go on the right side. And then it is the P mod 3. So therefore, 147 will go on the left side, 258 will go on the middle, and then 369 will go on the right. So, and then when we will form the item set, so we have to follow one principle, that is, let's say if we have the item set 1, 2, 3, 4, 5, then first we generate the item set 1, 2, then we generate 1, 3, then we generate 1, 4, generate 1, 5. And similarly, we will have the item set 2, 3, 2, 4, 2, 5. So we cannot make 3, 3, 5 is okay. So it should be that item set should be arranged in a order also. So we cannot make the item set 5, 4. Because why so? Because we must have the item set 4, 5, and the item set 4, 5 is same as the 5, 4. So therefore, if we maintain the order, so then there won't be any chance of the being the duplicate of the item set. Now, based on this principle, what we do it will has the entire transaction here using the hash structure. So how do you do it? So first is 145. So 145 means it should come on the left side because it start with 1. 145 is a transaction, it started with 1. So it should be appearing on the left side. So 145 will be somewhere here. And finally, the all item set will appear in leaf node. And in internal node, so when the leaf node size exceed the minimum number of item set, then we have to split that particular node so that leaf node becomes the internal node. What the point? These are the item set here, and this is the hash function. So if any item set start with 147, so it must move to the left side. So let's say here 145 on the left side. Consider this is not there. Okay. So this is entirely not there. So then we have only 145 on the left side. Then 124. 124 is again starting with 1. So then we have 124 here. Then 457. Again 45 is starting with 4. It will go on the left side. So 457. Then 125 again is starting with 1. So 125. Then 458. So again it will go on the 458. Okay. So now if you see here at this point here, you have how many? 1, 2, 3, 4, 5. 5 item set. But it was initially leaf node. I said the leaf node cannot have more than 3 item set. So therefore you have to split this one. Now you split it. Once you split it, then it will have again the same principle. So already 1, 4 is there. So next item is, what is that? Next item was 145, right? 145. So next item 1 is already gone. Then next item set is 4 and 5. 4 where it will appear? 4 will appear on the left side because here is 147 will come on the left side. So therefore 145 will go to the leftmost side. Now, what are the other items? If you see here, 1, 2, 4. 1, 2, 4, already 1 is this side, 2 means it will go on the middle side. So 1, 2, 4 will appear somewhere here. So 1, 2, 4 is already somewhere here.
So do you have doubt or full of doubt?
So in the last class, we started talking about the APID algorithm. So as I said, the basic idea.
So this may be
APID
revision of the
algorithm is
earlier
that
some of the classes.
If
Last,
an item set is
some of the
frequent,
content of the
all
previous
its
class.
subset will be the frequent. And then from there, the property we have seen, that is anti-monotone property. So there, what we have seen, if an item set is infrequent, so it all superset will be the infrequent. So now we just see the algorithm. First, let k equal to 1, generate the frequent item set of length 1. That means you first find the which item is frequent. So find the all frequent item set. Item set length 1 means that one item. One item means, so if find the all items which are frequent. So that is, you generate the frequent item set of length 1. Say if A is an item, A, B, C, D, these are the items. So then we'll say you find, let's say, A and C and E, these three are the frequent. Now what is the objective? We have to find the all frequent item sets. That means item set with length 1, item set with length 2, up to the total number of items. So let's say if it is k, so then we should find the all item set with length k minus 1, k minus 2, k minus 3, and starting from 1. So then how we do it? Generate the length of k plus 1. So it is k equal to 1. So I will generate the length of 2. First we generate the candidate item set from the length of the k frequent item set. So as I said in the last class, let's say, and here also, let A, B and C are frequent. From here we'll find the frequent item set of length 2. So this is all our on length frequent item set. So then we merge with A and B, we'll get AB. Then we'll merge with A and C, we'll get AC. Okay. And then we merge with B and C, so we'll get BC. And then what we said key, so this is the, and then what we have to do, prune the candidate item containing the subset of length k that are not frequent. So now we form the AB, AC and BC. Now we have to find the which item is infrequent and we have to remove it. Okay. So let's say if we find no item is infrequent, so that means all item set is also the frequent. Then what we have to do? Count the support of the each candidate by scanning the DB. So obviously how to find the infrequent item set and eliminate the candidates that are infrequent. So for the next stage, we are preparing the infrequent items, leaving only those the frequent item set. So for this example, let's say there is no infrequent item set. So then now we have the item set AB, AC and BC. Now we'll merge two frequent item set of length k to forming the k plus 1 frequent item set. So that is the generate the length k plus 1 candidate item set from the length k. We can merge in many ways. So one easiest way to avoid the duplicate, what we do it, we'll merge AB and AC. So while merging the two frequent item set of length say k, so it will form k plus 1. So while merging the two frequent item set of length k, you have to see the all items starting from 1 to the length k minus 1 must be identical. Okay. So what is that meaning? So suppose you are merging the item set x1, x2, x3, x4 to, so let's say xk. Similarly y1, y2, similarly yk. because all length, both length are same. It is possible, according to this algorithm, if we have x1, y1 is same, x2, y2 same, x3, y3 same, up to, if it is k, so up to k minus 1 must be identical. So in this example, AB, AC, so we are marching k equal to 2, so that is k minus 1, so that is 1. So these must be the same, A and A must be the same. Then it will form the, let's say ABC. So we want to form the from k item set to k plus 1 item set. Now what happens if you merge AB and BC? This is according to this algorithm we cannot merge. Okay, but this is possible. A, B, C is also possible. So first we will form like this formula, and then we'll see the whether this ABC also can be formed or not. So after forming this one, what we have to see? We have to see the support of the each candidate item set, they are frequent or not. So then how do you see? Let's say we found, so this is also same that let's say ABC. So you found the ABC is a candidate item set. Now what you have to do? You have to search in the data set whether ABC, what is the support of the ABC, and then we should conclude that ABC is frequent or not. Right? So this is the policy. And then again you have to proceed further up to k minus 1 frequent. If the total length is t, so you have to go up to t minus 1, including t also okay, but from t you cannot generate any other rule, which already it will be generated. So now what do we do it? How we can make this algorithm much faster? Faster in a sense, what after generating the candidate item set, how we can count whether those some of the candidate item set is infrequent. Obviously, you have to count the frequency of the each candidate item set, and how we can speed up this process. That is means counting the support of the each candidate item set. Okay, so that is the objective here. So here one example. So suppose these are the set, these are the transaction. So from here, bread, milk. Okay, so we'll generate the candidate item set of length 2. So bread, milk will be 1. So frequency of the candidate item set. How do you do it? So let's say here in this example, yesterday we started with every item will arrange in lexicographic order. So here, so beer is somewhere here, right? So beer is somewhere here. So beer will appear first. Then we can avoid the duplicate, as I said in the last class. So then beer, then one item set. Okay, that is the all item set is candidate 1, but you have to find which item. So you can give some numeric value. Let's, without looking into transaction, you can generate the all candidate item set from the this set of item 1, 2, 3, 4. So it will be 1, 2, then it will be 1, 3, it will be 1, 4, then it will be 2, 3, it will be 2, 4, right? So this is 2 items that I am generating. Then we'll have the 3, 4. So now we generate the item set. Let's say you write it 1, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. You generate the all frequent items, all items, candidate item set with length 2. Now what is the task? Some of the item set be infrequent, so you have to identify those. So what you have to do now, you go to the database transaction data set. What you can do, you can see 1 and 2 how many times it appear in the data set. So 1, 2 means what? Beer and bread, how many times it appear. Instead of doing finding the each candidate item set and transaction the data is many times, because transaction data set in general is stored in the, let's say, in hard disk, so you have to access so many times. So instead of that, what it can be done, from this transaction we find all subset with cardinality 2. That means we find first the candidate, so we find the item set with 2. So here item set bread, milk will be 2 only 1, right? So now you search the inside we search this candidate generated candidate item set, how many times this is appearing. So wherever it is bread milk is there, so we will increment, but bread milk will appear only once here because each candidate item set will, there won't be any duplicate here. So then we'll update that one. So we have to search the entire candidate item set. Similarly, say in the second transaction, bread, diaper, and beer and egg is gone. So then you arrange them. So beer will come first, then bread, and then diaper. So then it will be 1, 2, 3. So from 1 to 3, you generate the item set 1, 2, item set 1, 3, and 2, 3. So you search this from this transaction, you can make 3 subset, and from these 3 subset, you search here. So first you search for 1, 2, okay, then you search for 1, 3, then you search for 2, 3. So therefore, again, you have to length of the candidate item set. So number of candidate item set with length 2. Those many times you have to say, let's say it is here in this example 1, 2, 3, 4, 5, 6. So out of 6, because this is 4, okay. So 6 out of 6. So you have to search once for 1, 2, where is 1, 2, then 1, 3, and then 2, 4. Okay, so this is the way we can search. But to reduce the number of comparison, store the candidate in a hash structure. To speed up the further speed up, what we can do it, instead of putting the candidate item set in no structured way, what we can do, we can put the candidate generated candidate item set in a hash tree, and then we can speed up the entire search process. So that I will discuss next. So here, suppose you have the 15 candidate item set of length 3. So this is how we'll generate it. So we had the item set, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So we generated from here, we generated the 15 item set. So obviously there will be, say, let's say 9. So combination will be NC, so 9C3. But out of that, 2 candidate item set maybe there are infrequent, so some of them are the infrequent, so therefore we remove them. So now what we have to do, I am saying ki 2 item set were infrequent. 2 item set, because of the 2 item set, 2 means item set with length 2. 2 means here 2 item set. Item set with length 2 are infrequent. So therefore when you merge the two item set, then it will make 1 3 item set. Okay. So while this one, and then we found that is the case here, that we got the 15 candidate item set. Are you getting? So earlier what we are doing, we have the 1 item set, from there we are making 2 item set. After generating the candidate item set, we will search in the database. Okay, and then after generating the 2, after confirming the which are the item set are frequent, now we'll move to the generating the 3 candidate item set, right? So now question is, we generated the 3 candidate item set and there are 15 candidate item set. Now what do we do it? We put these 15 candidate item set into the hash structure. So now we will generate the hash structure. So this is hash function is something here. So if it started with 147, then it will go on the left side. If started with 258, what is 147 and 258? These are the item. Because after arranging in lexicographic order, we gave some numeric value, that is 1, 2, 3, 4. So these are the way. So here hash function is like hash of this P is like P mod 3. So why 3? Because the length of the candidate item is 3, so therefore we have taken 3. And we have this set of the candidate item set, and then we have to put these item set into the hash structure. So now hash function is this one. Okay, so let's say if this is 145, that is 1, it should appear on the left side. Similarly, 368 started with 3, so it will be hashed on the extreme right side. So this is the beauty of the hash function. Now we'll generate the hash structure. So first was, let's say we start from here. is so 145. So it should go on the left side because as structure says it started with 147, it will go on the left side. So this is 1 4.
If you have any question, you can ask parallelly
Then
also.
1 2 4 again it will go on the left side. So 1 2 4. Okay. So instead of writing this way, let me write like 1 2 4. Then is 4 5 7. So 4 5 7 again in the left side. So 4 5 7. Then is 1 2 5. Again it is on the left side. 1 2 5. Next 4 5 8. So it should be on the left side. 4 5 8. But here problem is each node, leaf node, can contain a maximum number of item set. So here we fix it 3. But here we see is actually it is more than 3. So then what we have to do? These nodes should be splitted. So these are the terminal node. These are the initially these are the terminal node. Now you started putting the candidate item set into the hash tree. So now what I said is this was the terminal node, but if it exceeds the maximum number of candidate item set, which is 3, we decided, then what we can do, again we split the node into again the 3 child node. So therefore what we have to do, now the new structure, instead of having this leaf node, we should again come up with 3 nodes. This is 1, this is 2 and this is 3. So again the same 3 structure will come, and again we have to arrange this node into the this node and this node, because always the candidate item set will be this candidate item set will be into the leaf node. Now what we have to do it? So this has to be splitted. So now if we split it, so if I read out it, so initially we had 3. This was attached with here. Now we have to split. Then again we have to go with the same hash function. 147 will come left side and 369 will go on the right side, and then 258 will come in the middle. Now using the first item we hashed already. Now in this case what we have to see? We have to see the second item. What is the second item for 145? So it is 4. So 4 means it should go on the left side. So we write 145. Now 1 2 4. So 1 is already done. 2 means it will go on the middle. So then this will be 1 2 4. 4 5 7. So it is 5. 5 means on the hash function. So it will go on the middle. So it should come here 4 5 7. Next is 1 2 5. 1 2 5 means it will go 1 2 5 here. Next is 4 5 8. So it is already 3. So then we cannot accommodate 4 5 8. So again we have to split this node. So again we should split this node. So I deleted what was there, 1 2 4. So already this is 2, this is 1, this is 3, this is 2, this is 3. It is not 1, actually 147. It is 258 and 369. Now what we have to do? It was actually 1 2 4. So now you split 1 2 4 based on the third item. So because this is length is this was 1, this is 2, and then this is 3. So third item is 4. So it will come here 1 2 4. Then is 4 5 7. So 4 5 7 is again 7. So it will come again 4 5 7. Next was 1 2 5. 5 means 1 2 5 here. Is it okay? Now how far we came? Then 4 5 8. Where is 4 5 8? So 4 was initially here, then 5 means here, and then 8 is again here. So 4 5 8 will come here. So out I completed up to 4 5 8. What is next? 1 5 9. 1 5 9 means this is 1, then 5 means again here, and 9 means right side. So here we should write 1 5 9. But next 136. 1 means here, then 3 is here, and there is no note, so we have to write 136. Next is 234. 2 means here, okay, so therefore you have to write 234. Next is 567. 5 means here second, and then you have to write 567. What next? 345. 34 means on the right side, okay, 45, so you write 345. Then 356, it will come on the rightmost side, and then you write 356. Then is 357, it will again come on the right side, and you write 357. Next is 689. 6 means again on the rightmost side, and then you write 689, but it is exceeding 3, so then you have to split it, okay. So then you have to remember what are the items. This was 345, 356, 357, and 689. So these will be again splitted. So this is one, this is one, this is one. So 3, 4, 5. Now you see only the second position which item is there. Second position item is 4. So therefore it will come here 3, 4, 5. Next is 3, 5, 6. 3 is already done. 5. 5 means it is on the middle. So it will come 3, 5, 6. Next is 3, 5, 7. So it will come 3, 5, 7. Next is 6, 8, 9. 6, 8, 9 means 6 is on the rightmost side, and next is 8. 8 means, so this is here. Where is 8? So you have to come 6, 8, 9. Next is 3, 6, 7. 3 is done. 6 means rightmost here. Okay, so then 3, 6, 7. Then is 3, 6, 8. So 3 is here. Then 6 on the right side, rightmost side, and then 3, 6, 8. So then all 15 candidate items set, I use the hash structure. Okay, so this is can be seen here. So you can go back and see here. So on the rightmost there was 367, 368. So 367, 368, and then there are 3 items. Okay, 3 items here, and then you have the single item here, single item here, single item here on the second level. There are 2 items here, and then last level you have the 5 items. So you have 5 items here. This is single, this is single. You have 2, and this is single. So that we form the structure, hash structure. So you have to do for the each candidate generation. So that means item set with length 2, item set with length 3, item set with length 4. Each time you have to generate this hash tree. Now what next? What was the objective? After generating the candidate item set, we should find the which item set is frequent or not, right? So that was the objective. For that, what you have to do? We have to see the transaction database. While generating the candidate item set, we are not seeing the transaction data set. Please note that while forming the candidate item set, we are not seeing the transaction data set. But obviously, what are the things are given? So which item sets are the frequent item set? From there we are generating. Okay, and then out of this one, some of the item set will be the infrequent. So let's say maybe 2, 3, 4 or 5, 1, 5, 9 might be. So 2, 3, 4 is here, and 1, 5, 9 will be the infrequent. Now we'll see how from the database we can declare some of the item set is infrequent. So after hashing 147, this is all the items where we hashed with 147. So that is the showing here. So this is only hashing with 258. Initially it started with 258 first, and then you see is here item set with 369. So this is the 369. Now question is, given a transaction T, what are the possible subset of size 3? We have a set of transactions that makes a database. Now what I see, what I said key, for each transaction data set, you make the all subset and then you search the in the candidate list. So let's say we are giving a transaction data set. Now how we'll form the all subset. I already said, so if you have the transaction data set 135, so you generate the all subset. How do you make the subset of item set 2, 1, 3, 1, 5 and 3, 5. So here one example, a more systematic way can be done here. It's very simple, it's not that much difficult. So we have the transaction data set 1, 2, 3, 5, 6. Okay, we have to generate the candidate item set with length 3 from this transaction. Please note that earlier what we did from the entire item set. Now we are doing from a single transaction. We have a set of transaction, we have to go each transaction and then we have to update the frequency of the candidate item set. Now, so given a transaction, what are the subset can be formed? And then those subset we should see into the hash structure. So here we go. So we have to make the 3. So therefore what we can do is we can make like that. In the level 1, what we can make 1 and then any combination of this one. So that is we write 1 and any combination of this one. Similarly 1, 2 with any combination of 3, 5, 6 and then 3, 5, 6 and then 2, 3, 5, 6. You got my point here? So we are given the transaction is 1, 2, 3, 5, 6. You have to generate the all item set with length 3. So then in the first what we do it 1 and then 2, 3, 5, 6 we write. That means any transaction will start with 1. Then we can have any item set start with 1 and then we can have the item set which start with 2, item set which start with 3. In the same way, I said just few minutes before 1, 2, 5. So what we can do it 1, 2, 1, it can be 1, 5 and then we can have 2, 5. So this is actually written instead of writing like that, what I can do 1 and then 2, 5. So I can take 1, 2, another is 1, 5. So similarly, what we can do is 1, 2, 3, 5, 6. Similarly 2, 3, 5, 6 and 3, 5, 6. Now in the second level, what again you can do the same thing. 1 is already taken, you take out 2 and then 5, 6. So you can have the combination any 1, 2 is fixed, then you can take the combination 1, 2, 3, 1, 2, 5, 1, 2, 6. Similarly here 1 is common and from here what in earlier case what, so let's say this is 1, 2, 5, 6, let's say. How do you do it? So you can have with item set 2, you can have 1 and then any combination with 2, 5, 6. So that is 1, 2, 1, 5, 1, 6. Next what we can do it 2 and any combination from 5 and 6. So 2, 5, 2, 6. And then what we can do is 5 and there is no item 5, 6. So this is the candidate item set with 2. So that is written, that is done in a more structured way. So that is 1 and any combination of 2, 3, 5, 6. So from here what we can do, we can fix 1 and then 1, 2 and any combination of from here. 1, 3 any combination of 5, 6. 1, 5 any combination of that. So but there is only one item. Similarly from here what we can do is 2 is fixed, from 2 we can make 3, 2, 3 is fixed and then any combination from 5 and 6 and 2, 5 and 6. And similarly here 3, 5, 6 is, you don't have much choice, 3, 5 and 6. Now here you make the subset 1, 2 any combination of 3, 5, 6. One combination will be 3, another combination will be 5, another combination will be 6. Similarly here 1, 3 is fixed and then you take 5, 1 another time 6. So 1, 3, 5, 1, 3, 6. Here you don't have item, so it is 1, 5, 6. Now 2, 3, 5. So one is 2, 3, 5, another is 6, and here is you don't have choice, so 2, 5, 6. Here also you don't have choice, 3, 5, 6. So that way from each transaction you have to first make the subset. Now what next? This subset is the subset obtained from the transaction. That means it has the valid existent into the data set. So if any one of this one is already the transaction, it is there in the candidate set, that value will incremented by 1. Okay, so now you see here, these are the initially, forget this part. We generated this few minutes before we generated this part. Okay, so you cross it because you consider this is not there. This is not there. So we generated few minutes before. So now what is the task? Task is that one transaction came. So this transaction we have to, from this transaction, whatever the item set generated, we have to update the its corresponding frequency. So these are the candidate item set. Initially all are zero because these all three generated from the only the set of items. It is nothing to do with the each transaction. So therefore each frequency is zero. Now what you have to do? You have to go to the transaction, find the all subset, and that each subset you match with the this candidate item set. That was the initial objective. Here we will do the same thing, but more systematic way. We generated the candidate item set. Here, this is the candidate item set. We generated the items, all subset of the item set with length 3, just few minutes before, because this is a transaction. Okay. Now, how do we form it? As I said, it can be transaction can be 1 plus any combination of from here. But all this starting with 1 will be obtained from the left subtree because it is everything is structured has in such a way. So any combination with starting with 1 will be obtained from here. Similarly, any combination starting with 2 will be obtained from here. Any combination with starting with 3 will be obtained from here. But everything is available in the leaf node. So you have to go to the leaf node. Now here there is no leaf node, so directly whatever the combination will come, you can search only this position. Now here 1 is done, then what do you do it? You see the second position. Second position is 2. Okay, so then any combination start with 2 will be obtained from here. So here we go. So any combination 1 is already done. Okay, you leave it. So because we pointed here, now any combination, what are the combination? Or the combination will be 2. In the same way, it can be 2 and then any combination with 3, 5. So that is 2 and 3, 5, 6. Where it can be obtained? Any 2 will be obtained from this position because this is the 2 position. And now 1 is already there. Now if from here what we can get 3 and any combination of 5, 6. So where we will get 3? So 3 will get from here. And now is 5. 5 where you should get again from here. So therefore this 2 is pointing to this node and this node is pointing to this leaf node. Why? Because it is 3. So 3 and any combination must be in the rightmost position, rightmost child. Next you move here. So 2 and any combination of this one will be obtained here. There are only 2 leaf nodes. So the combination can be 2. Now you have to see what can be the combination from here. It can be combination 2, 3 and then combination of 5, 6. Then it can be 2, 5 and then 6. Okay. So from here again you can get 2, 3, 5 and 2, 3, 6. So and then 2, 5, 6. So these all 3 you have to search only here. No other places. Earlier we had to search the all candidate item set. So similarly 3 means any combination of this one is obtained from here. Okay. Now task is not yet completed because we are in a node, we are not in the leaf node. For this one is done, but for these two, that is this combination and this combination, we are in the internal node. So it should point to the leaf node. So now what is the task? So that is 1 is done, 1, 2 and 3, 5, 6. So now you have to split 3, 5, 6. 1, 2 is already done. You have to split 3, 5, 6. So if you split 3, 5, 6, so 1 can be 3. So that is, so 1, 2 is already done. So now next is it can be 3. And then 3 means it should come somewhere here. And then it is 5 and 6. So we can go next. So I said is 1, 2 and then you can take the combination from 1, 2, and 3. So 1, 2, 3, all 1, 2, and 1, 5. This combination is here. So I think I should go next. So 1, 2. What is the length of the item set? It is 3. So this is 1, 2, and you take any combination from 3, 5, 6. So it will form 1, 2, 3. It will form 1, 2, 5, and it will form 1, 2, 6. So now where do you get 1, 2, 3? See, 1, 2 is already we are here. 3 means it should be here. So we should search from here. Then 1 to 5. So 1 to 5 must locate in this box. Then is 1 to 6. 1 to 6 means we must search here. So therefore, for these 3 set of item, we will search here and here, not even here. So here 1, 3. 1, 3 means we'll search here. So we will have the combination 1, 3, 5 and 1, 3, 6. But it is not the candidate. So 1, 3, 6 is here. Yeah. So then you have to increment 1 because it was 0. So now its frequency will be incremented by 1. And 135 is not there because its subset was infrequent. So therefore its superset, including its superset, cannot be frequent. So that is actually it is not there. Okay, next what we have to do it. Now you have to come here. So 2 and any combination of 3, 5, 6. It can be whatever the combination you should get from this region only. Similarly here 3, 5, 6. 3, 5, 6 means we can get the combination 3 and 5, 6. So you should get from this region. So this region is like 3, 5 means you should get 3, 5. Sorry, 3 is already here. 3 was here, and then 5 means here, and then last one there is no. So you should get from this region.
Is it okay? Hello.
Yes, sir.
So class is done.
Yes, sir.
Okay, I will upload the video here. Okay, I stop the class today.